on last night's homework. We should have plenty of time to go over it. It's not due till today at 4 o'clock. So if we have questions on that, I will be happy to go over it with you. We're going to just jump right into this today. So this says area of a rectangle. I've got a little picture of a rectangle. Area of a rectangle in this lovely picture is supposed to be 80 square inches, or you don't have to write this or anything, but that would be the same as 80 inches squared, just another way to write it, so you don't have to square anything. It says find the value of x by completing the square. So how could I set up an equation for the area of this rectangle if I know the area is 80? Like, what would the equation look like? What would you do with that picture? Perfect. Length times width, right? So 2x times x minus 6 equals 80. Now, if we go through and multiply this, this is going to give us a quadratic, right? Because we're going to do a little distributive property. So we got 2x squared minus 12x equals 80. Now, I'm going to complete the square, so I would like my x squared term and my x term on the side, the same side, and any numbers on the other, which I have here. Would anybody maybe do anything before they tried to complete the square? Jacob, what were you thinking? Well, he specifically said the number, so let's divide by 2. All right, you guys can, you can't do this with variables, but you can always do this with numbers. All these guys are divisible by 2. So I'm supposed to solve this by completing the square. So what I'm going to do after I divide by 2, I'm just going to leave a little space to complete the square like we were doing yesterday. The other side of this, oh shoot, this would be 6. Sorry, I forgot to divide by 2. This would be 6. And then the 80 would become 40. But then again, I'm just going to leave myself a little space because it told us to complete the square. Okay, can anybody raise your hand and tell me how do I fill in the little blank to complete the square? Does anybody remember from what we did yesterday? Thank you for raising your hand. You do have your hand up. Go ahead. You take the thing and you divide by 2. Okay, so what would you do for this problem? Good deal. All right, b value divided by 2 squared. So negative 6 divided by 2 is negative 3 squared, and that's going to be 9. Okay, Braylon, how would you write the factored form of this on the left side?
X minus 3 squared.
Excellent. And what would you write on the other side?
Equals 40.
Excellent. Guys, calm down. All right. Now, all we're going to do here, this is nice for us, so you guys can see 49 is a perfect square, so that's awesome. So we're just going to take square root there, and we won't have to like break down a radical or anything because this is a perfect square. So x minus 3 is, don't forget we introduced the square root, so we have to put the plus or minus 7. Now, I'm going to add 3 to the other side. I should have given myself a little bit more space. So I have 3 plus or minus 7. Now, if that's 7i, we're done. If it's 7 radical 2, we're done. But if it's just 7, we can actually add these together. So 3 plus 7 would be 10, and 3 minus 7 would be negative 4. Are both of those solutions for this problem? So x is 10 and x is negative 4 for this problem. Okay, spoiler alert, one of those doesn't work. Does anybody know which one doesn't work? Why? You can't have a negative length. Okay, so these solve this equation, but in terms of this being attached to this situation, you can't have a negative length. So if I plugged in negative 4 for either one of these pieces, it would make our rectangle have a negative length, so we can't have that. So x would be 10 there. If, I'm just going to write this here, it asks you for x, so x here, the answer would be 10. If a question asks you for the dimensions, you can find that really easily by plugging it back in. So the dimensions, like if I multiplied, this would be 20, and this side would be 4. So if it asks you like for the dimensions or it asks you for the length and width, you can just plug your solution back in. But make sure your solution does not make one of the sides negative. Now, in this case, I have 2 times whatever my x value is. It is possible to get a negative answer for this, and maybe the expression, like if I had x plus 6 or something like that, it wouldn't make the side negative. So I don't want you to automatically think that a negative answer won't work. You got to look at the original problem, see if you would plug that number in. If it would make one of the sides in the figure negative, then it doesn't work. If it doesn't make a side negative, though, it would work. All right, now, I promised yesterday I did not give you any A values other than 1, but today, unfortunately, we have to deal with an A value that is not 1. So the process for completing the square, I'm going to keep my squared term and my plain number on the same side, just like I did yesterday. So in this first equation, I'm just going to do one tiny thing, and that is to add the 5 to the other side to start this out. So I'm just going to add 5. Okay. Now here's the deal. I'm just going to kind of work on the left side of this equation, but you have to have the value in front of the squared term be 1. So if it's not, which it's not here, this is a 3. Here's what I'm going to do, but I'm only going to do this on the left side. Okay. I'm going to take a 3, which I can actually take out of both of these terms. And that would give me x squared plus 2x. And just like we did yesterday, I'm going to leave myself a little space to complete the square. And I had moved that 5 to the other side, and I'm going to keep my equation balanced, so I'm going to leave a space to complete the square. Okay, now, in the little parentheses, this is exactly like the problems we were doing yesterday. You're just going to grab your b value, which is 2. It's the b value divided by 2 squared. This will be nice for us because this is just 1 squared, which is 1. So I'm going to add 1. Now let me ask you a question. What did I really add to the left side of that equation? 3. Does this make sense? So if I put this in the parentheses, I complete the square here, which I did. This has a 3 in front of it. I really added this times whatever I put in here. So I really added 3 here. So on this side, I have to add 3. If you have a number out in front of the parentheses, just multiply it by what you put in there, and then that's what you have to add to the other side. So that's really tricky. Here, I'm just going to write this above here. It's because on this side, I'm doing 3 times that 1 that I added there. So you have to be careful of that if you've pulled something out in front. Otherwise, this works extremely similar to yesterday. So I've just got a 3. I'm going to scrunch that perfect square trinomial, multiply to get 1, add to get 2, x plus 1 times x plus 1, or just x plus 1 squared. The other side, we're going to add 5 and 3. That's going to be 8. Now, these can be a little bit more complicated than what we did yesterday. Because I've got this number in front of the parentheses, I actually have to divide here. And so we're going to end up similar process, but just a little bit more tricky to work with, because we're going to have to take a square root, and we're not going to have a perfect square on the bottom. All right, so we're going to see what you guys remember from Algebra 1. All right, so I've got x plus 1. You can't have a square root on the bottom. I'm so glad you said that. Okay, this is like a, Miss Grody, you're a jerk for giving us this problem kind of a thing. All right, now, this would be square root of 8 on the top, square root of 3 on the bottom. You can break down 8 under a square root. Let me just write it to the side here. So under a square root, 8 would be 4 times 2, so that's going to be 2 roots of 2. So really the top of this would be 2 roots of 2. And then unfortunately I have a root 3 on the bottom, which you're not allowed to have a radical in the denominator. Does anybody know how to get rid of the radical 3? Multiply by the radical. Okay, so this process, this is called rationalizing the denominator. So what I'm going to do there on the top of that, I should have given myself some more space. We're going to have a 2. Now, you have square root of 2 times square root of 3. You can always multiply radicals together. You literally just squish them under the same radical. 2 times 3 is 6. Now, I'm going to write this. the bottom of this would become the square root of 9. But the reason that this always works, if you multiply a radical by itself, it should create a perfect square, canceling the radical out in the denominator, so that denominator will end up being 3. So I know that's a lot, but that's what we got going on in the problem here. So I have x plus 1, all simplified, plus or minus 2 roots of 6 over 3. The only other thing I have to do is just move the 1 to the other side, so just minus 1. And we're just, we can't do anything more here. Negative 1, sorry, plus or minus, and then the fraction, 2 roots of 6 over 3. So that's kind of garbagey, but that's what happens a lot of times if you have a number in front of the x squared. It's not terrible to work with, it's just a little bit more time consuming. And that's a really good review to rationalize the denominator. Is anybody having a question? Okay, let me try one more with you guys. Again, this is kind of already set up for us. I'm going to take, I don't have a lot of space here, both of these terms I'm going to take a 2 out of, just on the left side. And so I'm going to have x squared minus 4x. I'm going to leave a space to complete the square. On the other side, it was just already set up for us to just be the plain number was on the right side. I'm going to complete the square to get my perfect square trinomial. So I'm just going to grab my b value, which is negative 4 divided by 2 squared. So negative 2 squared, which is 4. So if I complete the square, what did I really add to this side? 8, right? Because this would have this 2 out in front of it. So over here you have to add 8, and the way we're getting that, it's because you're doing 2 times what we put in there to complete the square. So 2 times 4 is where that 8's coming from. This one will be way nicer than the last question. Or maybe not. Actually, I just lied to you. Never mind. This would be x minus 2 squared. This will be 9. But because I have a 2 in front, I don't have a perfect square. We're going to have to divide by 2 here real quick. So you get x minus 2 squared, 9 over 2. Now, unlike yesterday, you're not working with perfect squares here most of the time when you have the radical or the number in front of the x squared terms. So I'm going to do little rationalize the denominator here. I can actually take the square root of the top of that, so that's going to be 3. But it's over the square root of 2. We got to rationalize, so just root 2. So this is going to end up being 3 roots of 2 over the square root of 4, which is going to simplify to be 2. The entire purpose of rationalizing a denominator, you're not allowed to have a radical in the bottom of a fraction. Totally fine to have it in the top. And the only other thing I'm going to do there is add 2. So my answer would look like this, 2 plus or minus 3 roots of 2 over 2. And we're just not going to add them together. You could create a common denominator and do that if you want to, but you can just leave it separated like I have here too. That's correct also. Is anybody having a question? All right. Now this last one, I have a fraction in front of my x squared. So just like the other questions, I have this spaced really weird. All right, so I have 1/2 x squared minus 2x. I'm going to move the 20. So to move the 20 to the other side, we're going to subtract it, equals negative 20. Now, you cannot have a number in front of the x squared when you do the process of completing the square. So whatever is in front of the x squared, we're going to divide by that. So I'm going to pull a 1/2 out in front. I'd have x squared. What would the middle term be? It's not 1. It's not negative 1. Okay. If you think about this, I'm going to take 2 divided by 1/2. If you divide by a fraction, it's the same as multiplying. Guys, come on. It's the same as multiplying by the reciprocal. So if you're taking 2 and you're going to divide that by 1/2, it's actually 2 times 2. So this is going to become 4x here. All right, and then on the other side, again, I'm just going to leave myself a little space to complete the square. All right, so this is actually similar to the last question we actually just did. Your b value is -4 again. So -4 divided by 2 squared, be -2 squared. I don't know why I just did that. So that's going to be 4. Okay, what did I really add to this side here? 2. So to keep my equation balanced, you're going to put this as a 2. The way you're getting that is you have 1/2 times the 4 because it's in that set of parentheses. So that's what I really added. So if you're balancing your equation, when you do the other side for these problems, just make sure whatever you add is going to be what you actually added to the other side. Now, this guy, we're going to have 1/2 x minus 2 squared. This will be -20 plus 2 would be -18. What would you do as your next step? I would multiply by 2, or you could divide by half, whatever's easier for you. In this case, we're going to get a nice perfect square on the other side. It's just going to be a perfect square in imaginary land because it's going to be negative. So we're going to take square root here. What are you going to write down as your square root of -36? 6i. Just put the little plus or minus in front of it, and then we're going to add 2, and we're not going to rationalize the denominator or do anything else. This would be 2 plus or minus 6i as our answer. Is anybody having a question? Okay, now the last little set here, and you guys will see this like all the time with stuff that you're going to do in pre-calc. We're going to convert these equations from standard form to vertex form using completing the square. So we did this in our previous unit, and I just had you do like -b/2a to find the h and k. I'm just going to show you another method for doing this, and this is a really important skill that you have to have, especially for pre-calc, because you're going to see this all the time. I've been working on this with a ton of people. I'm going to put this in the a times x minus h squared plus k form. Here's what I would tell you to do. If you have a plain number, just move it to the other side just for a second. All right, it's a little bit different than what we've been working on, so I'm going to write y minus 5, and then I've got x squared plus 8x, and I'm going to complete the square. I'm sorry. I'm going to complete the square on this other side too, so I'm going to leave that blank over there. The difference is we don't usually have a y in these problems when we've been solving them, but we're going to write this in vertex form. All right, we're going to take our b value, which is 8, divide by 2 squared, sorry, which is 4 squared, so I'm going to add 16. Now, I don't have any parentheses or anything like that in this question, so I just added 16, so I'm going to add 16 to that other side. So don't have to worry about adding more than that. All right. This guy over here, I have this -5 plus 16, so I'd have y plus 11. On this side, I have a perfect square trinomial because we set it up that way. So multiply to get 16, add to get 8. It should be whatever you squared. This is x plus 4 squared. And then the only other thing I'm going to do just real quick is move this plain number back to the other side. So I'm going to subtract 11 here. And then I've got my quadratic in vertex form instead of standard form. And if they ask you, okay, like what's the vertex? I could do my opposite copy. The vertex would be -4 and -11. The a value should be the same in both forms. So in that original problem, a value was 1, so you don't have anything in front of your parentheses. All right, now this guy. So I'm going to do the same thing. I'm going to move the 3 sorry, to the other side. Now, the other thing I'm going to do, we want our a value to be 1 if we're going to complete the square. So I'm just going to put a little negative out in front of this. I'm going to write x squared. It would become -6x if I do that. And then we're going to complete the square. Alright, so I put a little negative out in front. I took a negative out of both of these guys. That's all I'm doing. I'm just taking a little -1 because if you complete the square, you want that to be positive x squared. I am really sorry, guys. Okay, -6 divided by 2 squared. -3 squared. So I'm going to add 9. What did I really add to this side here? -9. Because of the -1. Alright, so this guy would be 3 minus 9, so it would be y minus 6. You have a little negative out in front here. This would be x minus 3 squared. The only other thing I have to do real quick is just move that 6 back to the other side to put it in vertex form. We want to have the y by itself. And then my a value should be the same in both forms, which it's -1 for both. My vertex opposite copy would be 3, 6. And that would put that in vertex form instead of standard form. Okay, now we're going to try these two at the bottom. These are trickier because they've got a number in front of the x squared. So first thing I would recommend, if you've got a plain number, just put it on the other side with the y just for a sec. We'll move it back, but makes it a little bit easier to work with. And what I'm going to do here, I'm going to take a 3 just out of these two terms, the linear term and the quadratic term. So I've got 3x squared minus 4x, leave a space to complete the square. And then I'm going to make sure whatever I add, I'm going to add that to the other side. So we're going to take, let me grab a different color. Alright, so we're going to do -4 divided by 2 squared, -2 squared, which is +4. What did I really add to that left? We added 12, right? 3 times 4, so you got to put a 12 over here. Alright, now, this is y plus, what, 19? 3. This is a perfect square trinomial. It's x minus 2 squared. Whatever you squared should be in the factor with the x. The only other thing I have to do is just move this 19 back to the other side, and then we have vertex form. So it'd be 3 times x minus 2 squared minus 19. Your vertex, if we do opposite copy, would be +2, -19. And I'm going to have us try one more here. This one has a -a value. Again, I would just recommend, if you got a plain number, I got a 3 here, just move it to the other side real quick. So I'd have y minus 3. And what I'm going to do here is I'm going to take a -2 out in front of the linear term and the quadratic term. So we have -2, change that to x squared, and then it would be minus 5x. I'm going to leave a space, to complete the square, and I'm going to leave a space over here to complete the square. Now, this one's a little garbagey because our b value is an odd number. So we're going to add a fraction here. So this is kind of tricky. Feel free to use your calculator. I'm going to take -5 divided by 2 squared, which is just going to become, we can't simplify that, but it's going to, I can square it. That's going to be 25 over 4. Okay, what did I really add to the right side of that equation? (50/4). Okay, so this how this would work. If you took -2 times this 25/4, you just multiplied the number times the numerator. It is negative, so it'd be -50/4. I'm going to write just underneath where I'm getting this. This would be -2 times 25/4. You just want to think about the -2 as being over 1, so it only gets multiplied by the numerator. Definitely should not have an 8 in the bottom, because that would not be multiplying by -2. So that's where I'm getting that. -2, just think of that -2 as being over 1, so it just changes the top. Okay, on this side, I'm going to grab my calculator. So we're going to take -3 minus 50/4. And I'm going to just convert that back into a fraction real quick. So this would be y minus 31 over 2. This side, I promise you, whatever you square, that's your factor. So I squared that negative 5 over 2. So this would be x minus 5 over 2 squared inside the little parentheses. And the only other thing I'm going to do is I'm going to add this 31 over 2 back to the other side. So this doesn't have a nice vertex. This wouldn't be something I'd be asking you to graph by hand or anything like that. But in vertex form, opposite copy, it would be 5 over 2 and then 31 over 2 as the vertex. Is anybody having a question? Okay. I was trying to give you every possible situation you could run into with those, because I've seen that a ton, like I said, in the